Hello everyone, myself I am Divya from Department of Chemistry, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. So in today's session, we are going to discuss a topic that is water and its treatment. So in earlier session, we have discussed that estimation of hardness of water by a complexometric method, that is EDTA method. So in today's session, that is continuation of water treatment, we are going to discuss a new topic, that is potable water and its specifications and the steps involved in treatment of potable water. What do you mean by a potable water? The drinking water which we drink, we call it as a potable water. So drinking water or a potable water, we also call it as the drinking water, we also call it as potable water, and it is safe enough to be consumed by humans, like which we can drink safe. And in most developed countries, the water supply to the households and the commercial industry needs the drinking water standards. So to improve the drinking water standards, we are going to purify the water, or we are going to treat the water. Drinking water or potable water, like it is fit for human consumption, like whatever the water we are going to consume or we are going to take, it should have some requirements or it should meet some specifications. So coming to the potable water specifications, first it should have a sparkling clear and odorless, and the taste should be pleasant and perfectly cool, and its turbidity should not exceed more than 10 ppm. It should be free from the objectionable dissolved gases like hydrogen sulfide. And one more specification we have is it should be free from the minerals such as lead, arsenic, chromium and the manganese salts. And alkalinity should not be high, and also the pH should be 8.0, and it should be soft. These are the specifications. And more we have is total dissolved salts. The water contains the dissolved salts, so those total dissolved salts should be less than 500 ppm. It should be free from disease producing microorganisms. And also, like in water, if we see, we can see minerals like chloride, fluoride and sulfide. So these contents should be, like chloride should be 250 ppm, fluoride is 1.5 ppm and sulfide is 250 ppm respectively. So these are the requirements or the specifications of potable water should contain to be consumed by humans safely. The next topic in the potable water is steps involved in treatment of potable water. To prepare a potable water or to get a drinking water, the water should be processed step by step, or it should be treated step by step, so that finally we can get a safe water or a potable water for the drinking purpose. So what are the steps involved, we are going to see in this topic. So coming to the first, we are going to take our water from any source, and then see, water from source is taken, and then water is supplied or it is moved to the coagulation and flocculation. Next is sedimentation. From the sedimentation, filtration, and finally we are going to do disinfection. And the water here, when it is purified under disinfection, now this water is sent to the community for the used. So treatment of water for drinking purposes mainly includes the removal of suspended impurities. For the drinking purpose, the water should not contain any type of impurities. So in this case, what we are doing is we are going to suspend the impurities or the colloidal impurities and also the harmful pathogenic bacteria which causes the diseases. So these are the following stages involved, or the following steps involved to treat the water for the consumption. So first step involves the screening. So under screening, what is happening is a large objects are removed. See, a large number of holes are present to the screens present there, which will help in the removing of impurities like wood pieces, leaves or the heavier objects. First we take a water from any source, and then from the water source we are that source we are going to send the water to a screening step. In the screening step, we are going to have some screens which are having some like a large holes. Now these holes will prevent the large number of like wood pieces or the leaves or the heavier objects from the screening. So a major part or the larger objects are removed from the screening. Now the water from screening is sent to the second step, that is aeration. Aeration is nothing but like exchange of gases between the air and water. What is happening in the aeration step is like gases are exchanged between the water and air. So aeration is the second step followed by the screening. The water is then subjected to the aeration, which helps in what? Exchange of gases between air and water. Now this increases the oxygen content and removes the impurities like in the aeration process, from the water we can remove the impurities like iron, manganese and dissolved gases like H2S, CO2 and NH3. These are the gases which we can remove from the water in the second step, that is aeration. Aeration is nothing but the exchange of gases between the water and air. So next step is coagulation and flocculation, which is followed by aeration. So whatever the water is purified under aeration process, now the water is sent to the coagulation and flocculation. We'll see now what is coagulation and flocculation. After aeration, coagulation occurs to remove the fine particles from the water. So whatever the fine particles are suspended in the water is removed. How it is removed means the fine particles in the water are of negative charge. So to remove these fine particles, we are going to add some positive charge chemicals. Those are called as coagulants. Chemical that is called as coagulant. So when we add this positive charge chemicals like coagulants to the negative charge fine particles, the water will be getting neutralized. Water will be getting neutralized where the fine particles can be removed. So under coagulation process, what is happening? Fine particles are of negative charge, and whatever the coagulants or the chemicals we are going to add into the water are the positive charge. Now these two charges will be getting neutralized and the fine particles will be removed. In this process, chemical called coagulant like positive electrical charge is added to the water, which neutralizes the fine particles. Now the fine particles or the impurity particles will be getting removed. The coagulants addition takes place in a rapid mix. When we are going to add the coagulants to the water, a rapid mix will be taking place, as you can see in this picture. High speed impellers are used to mix the water rapidly so that the fine particles can be removed. This is your fine particle of negative charge. Now you can see a positive charge particles are coming together and they are getting neutralized. Since the charges are now neutralized, the fine particles come together forming a soft fluffy particles called as flocks. Now the fine particles are converted into a flocks. So majorly we are using two types of coagulants as a chemicals. Here is aluminum sulfate and ferric chloride. As we are saying, coagulation process means we are going to add some chemicals that are coagulants, so it can neutralize the fine particles. So those coagulants are aluminum sulfate and the ferric chloride. So after coagulation, next step comes is flocculation. So here the water is gently stirred by paddles. Can you see here paddles? So under flocculation, it consisting of a chambers where a rapid mix of solution is taking place by the paddles, and here you can see mixing speed will be decreased by one chamber. So paddles in the flocculation basin, and the flocks come into contact with each other to form a larger flocks. So under coagulation process, we are going to have a fine particles that are converted into soft fluffy particles called flocks, right? Now these small flocks are coming together and forming a larger flock by using of this rapid mix. As you observe, here we send a raw water, and here we can see a mixing of the water so that the smaller flocks will be combining to form a larger flocks, and the speed will be decreasing. First it will be maintaining a high speed, then it comes to the medium speed, and from there it comes to the lower speed. The flocculation basin, as we have seen in the before slide picture, it will be consisting of a number of compartments with decreasing mixing speeds as the water advances through the basin. So we can see the mixing of speed will be decreasing by one compartment in the flocculation basin. This compartmentalized chamber allows the increasingly large flocks. So when you are continuously mixing, the small flocks will be combining together and form a larger flock. Now these flocks to form without any broken apart by mixing blades. As you can see here in the picture, so before we are going to have a negative charge. So remember, what do you mean by a negative charge? Negative charge means fine particles. That means impurities present in water are having of negative charge. So to this negative charge, we are going to add some coagulant or the chemicals which are of positive charge. Now this negative charge and the positive charge will neutralize the fine particles. So if you observe, coming to the coagulant, it will be forming a smaller flocks first. So in the flocculation, when you mix the flocks rapidly by decreasing its speed, it will be getting forming of a larger flocks. And now this larger flocks will be getting settling down. Now the water which is purified under the flocculation process is sent to the sedimentation. Sedimentation, what is happening in sedimentation? In before step, what we have, a larger flocks are there in our water. Now once these larger flocks are formed, they need to be settled down. They need to be settled down to easily removed. And this takes place in a process called sedimentation. In a sedimentation process, the large flocks which are formed in the flocculation process should be settled down when the particles fall to the floor of a settling tank. That means now the water is kept in the tank for several hours. So if you, after forming the larger flocks, leave the water for several hours so that all the larger flocks will be settling down to sedimentation take place. So you can see all these larger flocks can be settled down if you keep your water aside for few hours. The material is accumulated. What is the material here? The large flocks. The larger flocks will accumulate it at the bottom of the tank is called sludge. So if you see here, the bottom of the tank which is settled down, that you call it as a sludge. That means a large flocks are settled down. So that now we can remove these flocks or the impurities easily from the bottom of the tank. This is how a sedimentation process will be taking place, like we keep the water aside for few hours. Next, the water from the sedimentation will be sent to the filtration. Under filtration, filtration is a process where the solids are separated from the liquid. In water treatment, the solids that are not separated, in water treatment, whatever the steps we have seen in before things, whatever the solids or the impurities are not removed in the before steps, now it is removed by the filtration. So in water treatment, the solids that are not separated in the sedimentation tank are removed by passing the water through a sand and gravel beds. As you can see here, sand and gravel beds we are going to use so that the solid particles which are not removed from the sedimentation can be removed in the filtration process. With a flow of, like flow rate is 4 to 8 cubic meters per square meter of filter surface per hour. Now the rapid gravity filters are often used. When the filters are fully trapped solids, now they are backwashed. In this process, what you are seeing is a clean water and the air are pumped back up to the filter to dislodge the trapped impurities. The water carrying the dirt is pumped into a sewerage system, so there is one. Now alternately, it may be discharged back into the source water. Now whatever the unwanted water, the impurities we have removed, or that water we are going to send back to the river after a settlement stage in a sedimentation tank to remove the solids. So you can see here filters like this. We are going to send the water from sedimentation to filters. Now here filters, we are going to remove all the solid particles. So like these are passed from the sand and gravel beds, so that the solid particles which are not removed in the sedimentation tank can be removed from the filtration tank. Till filtration we have seen the water, so we are going to take a water from the source, and next water is sent to the screening, and screening to aeration to coagulation and flocculation. Now in flocculation flocks are formed, larger flocks are formed. Now these larger flocks with the water we are going to send it to sedimentation. These larger flocks are settled down. Now whatever the flocks are settled down, it is removed easily and moved to the filtration. These are the references for the potable water and its treatment. So in next class we'll see how disinfection works and how we are going to add other chemicals to the water so that the water is completely purified and it is safe for drinking purpose.